Okay, everyone, it's 11:30. I'm going to get started. Before I continue with the chapter and also make the announcement, do you guys have any questions or concerns about the course or previous chapters? Okay, so just ask me anything during the lecture or anytime. So first of all, I scheduled makeup exams for you guys and I sent emails to you, so I make sure that you receive it. I usually send announcements through BBLearn, but I thought maybe you don't receive emails or you just ignore them, you think they are spam or so they're not. So when I make an announcement, just like if you don't receive automatically emails, just go to BBLearn every day, like at least twice a day, to make sure you're up to date with the class. But for the things that are super important, I also send you guys emails, so I make sure that you receive them. But please check BBLearn because I cannot do that, because the Vandal web email doesn't work, so I kind of should manually enter your email addresses. So it takes me some time, so check BBLearn. So first of all, makeup exams. I scheduled several time slots and I took a picture, sent, emailed those to you. So you are welcome to attend any of those for exam 1, exam 2, exam 3 to increase your grades. As you may know, I'm not scaling your tests at the, or like your scores at the end, but I'm giving you tons of opportunities for extra credits. So and then I'm providing you with makeup exams and like makeup quizzes. So as long as you want to do well, you can. So any question about that? Yes?
So I'm looking at the retake schedule, and there's retake scheduled for Monday, November 29th, and Tuesday, November 30th. We will not be. That's next week. We leave this week, right?
I thought I put the schedule right.
Never mind.
Yeah, I didn't put anything for your break. Yeah, don't worry about that. It's like the week before, and then I didn't schedule any test before your exam because your exam 4 is on Friday. I want you guys to go to your tutoring sessions and I want you to study for that test because the materials would be it's more difficult. So I didn't schedule any tests those 2 days. But I have several hours, so hopefully you can attend one of those if you can and if you want to increase your grade. And also, if you are like hesitant whether or not you want to take it, just take it and I consider your highest grade if you already have a score. So don't worry about that. And for chapters 1, chapter 1, 2, 3, 4, I posted the study guides. I emailed those to you and posted them in the website too. So those basically makeup exam 1 and 2 would be only from the study guides. So if you study those well, you can do really well on the exam. And also for your final exam, as you know, it's accumulative. It's just from chapters 1 all the way through 10. To decrease the pressure off of you guys, I'm also going to ask you questions in your final exam from chapter 1, 2, 3, 4, only from the study guides. So it would be more manageable for you. So if, for chapter 1, 2, 3, 4, you can only study the study guides and answer all the corresponding questions. But for the other chapters, I'm going to post also study guides, but I cannot only ask from those because they need like calculations. I can just, it's not possible. It's kind of like I teach you what is multiplication and then just ask you from like limited number of questions that I post. It's not possible. But for the theoretical questions, I ask from the study guides. Is this clear? Good. Any questions? Okay. So I'm going to post your quiz for today, and I'm going to give your tutor the questions. So help you with the quiz 4 and for your exam in general. So I highly encourage you to go to your tutoring session for 2 reasons. One of that is getting the 10 extra points credits that I assign. And the other one is that she's going to help you solve the questions and answer your questions. So I highly encourage that. And the same thing for your exam, that when you come after the break, the days before, I'm going to give her the exams, so she prepare you for the exams. So I highly encourage you to attend tutoring sessions. And I had students emailing me asking me about the schedule, when is the final exam, when is exam 4. I'm following Professor Stelz's schedule. The only thing that sometimes I go out of my way is for extra credits, makeup exams and so on and so forth, so things to help you increase your grades. Other than that, we stick with Professor Stelz's schedule. The only difference is that I'm not going to cover chapter 11, as I mentioned, because I don't have time for that. If I could, I would, but we don't have time for it. So your final exam will be from chapters 1, 2, 3 till 10. And your exam dates are listed in the syllabus. So just refer to that. The same thing with the quiz deadline and that. Any question about anything that I said so far? Okay, now, we reached to the point in chapter 9 that it needs more attention from you guys, and it needs you guys to study, because the materials are becoming denser, and it needs more attention. So to encourage you guys to study and also increase your grades, and also encourage you to increase your grades, I assigned an assignment today for you, which is the following. So first I'm going to say the good things. So it has 20 extra points that I'll be adding to your exam 4. So if you do that and you get 50 in the exam, you get 70, so you know what that means. You have 20 extra points, which tremendously help you to increase your grades and to learn. And to demonstrate the point, so what you're going to do, and I'm going to write this now that I'm also almost done explaining the other announcement, I'm going to write this down. So this is your assignment homework for today. So you go through your book, and just before coming to the class at 10 a.m., I just did that myself, so you know what I mean. So you go to sections 9.4, 9.5, 9.6 in your book. And now I'm going to teach you those. So I just thought to make an announcement at the beginning of the class. So 9.4 is the Bohr model, 9.5 is the quantum mechanical model, 9.6 is quantum mechanical orbitals and electron configurations. What I want you to do is to go to your textbook. All of you should have e-text. Even if you didn't set it up, just go to the website. I listed the instructions. If you have difficulties, just email me. I guide you how to get access codes. You don't have to buy it, it's free. And go, open your book and read these sections that I just listed here and record your voice. So, I just did that before coming to the class, and I use voice recorder. It's super easy. Any media, all of you are much better than technology than I am. So if I did it, you can easily do that. So read that. And the reason that I'm doing that, because I want you to, if I wanted you to type, it takes so much time. I know you don't have that much of the time, but this takes between 15 to 30 minutes to do. So just read the book, and you don't have to read the pictures or record it. Just read the book, kind of like reading a newspaper or reading something scientific and learning, and upload it in BBLearn. And to demonstrate, I also have BBLearn open, and as I said, I just did that before coming here. And what I'm gonna do, I go to the student preview. I'm going to open extra credit for today's date, so you won't be having dates mixed up. I still didn't open that. And then when I go, so I just did that as a demonstration in November 10 or, I just opened that here. It was here. Maybe because I exited the student preview. Anyway, you can just, for some strange reason now it's not showing. Maybe, Oh, maybe, oh, that's it. So the student preview, because I exited that, now it didn't save. Anyway, I just recorded and I just did it in my phone and then went to BB Learn in my phone, uploaded that, and then submit. And it takes like 1 or 2 minutes. So don't stress about it. It takes like some time. And it was like, for me, it took like 40 minutes because I was doing other things while I was doing that, checking emails and so forth. You don't do that, it's just like a study. So, and it was like 50 megabytes. So it's easily, uploadable. And if you want extension on this, if you cannot do it for whatever reason, just email me and then do it as soon as you can. So I know that you want to get the extra credits, but you don't have time or you cannot do it. Any questions? Yes.
So just to restate it, we just go through and record ourselves on
Just audio, So you go, for instance, and I can just do that, I just wanted to demonstrate, but for some reason it didn't save. Anyway, so you go, say like 9.4, the Bohr model, atoms with orbitals. When an atom absorbs energy in the form of heat, light, or electricity, it often re-emits that energy as light. For example, a neon sign is composed of 1 or more, and then you do that for these 3 sections.
Okay.
So kind of like,
read it all the way through the book.
yes, these 3 sections, which would be like, in your e-text, you go here to e-text, you go to chapter 9. For some reason now it's like super slow. But eventually when it opens up, so for me now, because I was reading just before coming to the class, it was on 9.7. But you go to 9.4, start reading this. And as I said, you don't have to worry about the pictures or like, just like the text itself. Go to the next section, this, and this. That's it. Any question about that? Yes?
So just clarify which sections we read.
So I just wrote that here. 9.4, 9.5, 9.6. I mean, you're welcome to read all the sections, but this is the one for the extra credit that I want you to have. Yes?
Do you want us to read through the example problems in each
You
section?
don't have to, but I highly encourage you to do because, when I designed the test, so I'm going to refer to the examples. And I realized just by doing the example, one of the questions had an error in it, but when you see the answer, the answer was 3, but it was 5 specified. So when you read the description, you see why, So if you ever see an error in the book, that's possible. Don't think that it's impossible. And that's it. The other thing for makeup exam 3 that I'll mention makeup exams, I use self-assessment quizzes that you did previously for chapters 5 and 6, and quiz 3 and exam 3. So if you do know them well, you do well on makeup 3 exams. Yes?
Is this due on Friday?
This is due Friday, but if you cannot do it on time, just email me so I know that you want more time and I give you extension if you cannot do that. And during the break, I'm going to listen to you all and give your extra credits so you'll be up to date with the grades. Any other questions? Okay. So just email me, at any point, if you have any questions about this course, any concerns about quizzes, exams, homeworks, just email me and I'll be happy to answer your questions. So this is your homework, as I mentioned, 20 points. And I'm going to write it here. Read these sections, record the audio, and if you do video, it would be like so large, just do audio, and upload in BBLearn. Okay, and ask me any questions you might have. So now, in the previous session, we talked about the Bohr model. Atoms with orbits. And in the study guides that I posted from previous chapters, including chapter 4, I also have information about atoms, molecules, electrons, protons. So does any of you remember any of the models that you studied before about the atoms? So, or how, yes, yep, yes. So can you explain what it was?
It was an atom was basically something in the middle that had electrons all inside.
Exactly. So there were scientists way before, Demetrius, or let me see if I pronounce his name. Probably now he's shaking in grave because how I pronounce his name. Okay, Democritus. Okay, that was way off. And Leucippus. So these guys previously, way back, they said that atoms cannot be, so atoms are ultimate constituents of elements, and they are indivisible. We cannot break them down to other particles. And then it was not that well established, in the same way that I couldn't pronounce their names, so many people didn't care. It was until John Dalton that he said the same thing, but it was now established. But these Greek philosophers, they came out with this theory way before then. And they thought that atom cannot be, divided to smaller particles, or it doesn't contain anything smaller than that. But afterwards, some scientists like Thomson, they realized that there are other constituents to atoms. And can anyone tell me what they were? So when you think of atom, what does it have? Exactly, they have electrons, protons, neutrons. So at the time, as your friend mentioned, they were a model that was saying that we have a positive cloud in a sense, or kind of plum pudding model, or you can think of it as a blueberry muffin. Any dessert that has kind of particles, kind of blueberry, or we in Iran we were saying raisin cookies because they are popular in Iran, so they have these cookies that they have raisins in between them. So to visualize, Thomson said that atoms have, in general, they have a positive charge, that they are protons, and they have these dots that they are blueberries or raisins or any other types of dessert. They have negative charge in between. So to demonstrate that, they thought at the time that this is, atom that is kind of the positive cloud, and they have these negative charges inside of them, these dots. And then and afterwards, another scientist, Rutherford, wanted to prove or validate what his mentor, his professor said, and he did some experiment, and he realized that is not the case. So electrons in atoms are not just distributed like blueberries or raisins in a cookie. It's not like that. And he came up with the nuclear atom theory, which meant that protons are in the nucleus, and they have they are really heavy, and they take really small space, and electrons are in the kind of like, around the nucleus. So if you consider this as the nucleus which has the positive charge, the electrons, the negative charges are around them. So these are all, the steps, and you should know this for your makeup exam or for your final exam, because I'm going to ask you this. So it's kind of, and all of these are in your study guides to kind of like review. But now we want to talk about more correct models. So to just recap, can anyone tell me what are the constituents of atoms? What does an atom consist of? Exactly, electrons, protons, neutrons. So neutrons they don't have any charge, they are neutral. And they are in the nucleus, the center of an atom. And then protons are also in the center, and we have like electrons around the atom. They have negative charges, protons have positive charges. Is this clear? So if you don't know the basis, that's why I'm posting study guides. I ask you guys to retake the exams, because if you don't know these things, anything else that I'm saying doesn't make any sense, because I'm talking based off electrons, protons, and these things. So now, these models were really old. They were really precious at the time. And as we said, the models, theories, they can be proven wrong. So scientists did experiments and realized that these are not exactly how atoms are. They were really valuable for the time, but they weren't exactly representative of how atoms actually are. So now in this session, what I'm going to teach you is how electrons are situated in atoms. This is the main goal. And we have like the Bohr model, which has its own flaws, but it really explains well the hydrogen atom. And I'm going to talk about the quantum mechanical model, which explains things much better and is completely correct, at least to date, but it's like more complicated. So is this clear what I'm going to talk about? Okay. So now, do you remember in the previous session, I guess I just bring a picture here to save some time. So do you remember I told you that if we have like visible light, and that was the question that I told you that I'm going to ask you in the exam. If we have like visible light and then pass it through a prism, we see a continuous wavelength of different lights. But if we do that for hydrogen or like others, as you see, we see like just like different lines. We don't see a continuous spectrum. The reason is because how electrons are situated in the atoms. So, and now that I have the picture here, I just use it. So you're going to read these yourself too. So probably you'll be doing much better job than me reading this. But here we have like a definition of emission spectrum. So if you pass, if you heat some element, or like give it energy, whether it's electrical or heat, or in general, it absorbs some energy when it emits, because now the element is unstable, it wants to go back to the previous state that it was. It emits some energy. When it does that, you see the emission spectrum. So here, just as we separated the white light from a light bite into its constituent wavelength by passing it through a prism, we can separate the light emitted by glowing hydrogen, helium, or neon into its constituent wavelengths. By passing it through a prism, the result is an emission spectrum. So is it clear what is emission spectrum? So if you have if you warm an element or just kind of like you have light shining through it, it absorbs energy. And if, it passes here, as you see, through a prism, it generates an emission spectrum, which are like individual lines. And as we talked about, if you do that for different elements, you see different spectra, right? So if I tell you that are these two elements, like this one, I give you this and this, and say, are these two elements the same? Are they? Why? Because emission spectrum is unique for each element. It's like fingerprints, You see that police use, fingerprint to, now they use DNA, all other things too, But in the conventional way, they use like fingerprint because for not two people, they have like, none of them, people have like separate fingerprints. We don't have two people that their fingerprints match. Okay, so it's just like the same for the elements. Anyway, so now this is the Bohr model. So now you should know Thomson's model, Dalton's model, and Rutherford's model. But this is the Bohr model, and it specifies that the electrons, they can be in specified orbits around an atom. Meaning that, here if we have, and these are, we call these Bohr orbits. So here, this is the nucleus, and here electron can be here, or here, or here, depending on how many electrons we have. Here, and these are circle, as you see. I'm just trying to regenerate what the book has. And here. So you never see an electron being here or an electron being here. Based on Bohr's model, electrons are like in a specified locations around the atoms that we call them orbits. And depending on how many electrons we have, they occupy these orbits. So one thing that is really important that you should know is that the closer these atoms, or like these electrons, let me use blue. So the closer they are, so an electron can be here. And the closer to the nucleus, less energy it has. And in general, in nature, all elements, electrons, everything wants to be at lowest energy possible. Is there any questions? Just interrupt me if anytime you have any questions, Is there any questions? Just sometimes I struggle to demonstrate what I want to say in English, or looking for words. I know sometimes it could be difficult to understand what I'm saying. So just interrupt me. I won't be offended or upset or heartbroken. Just tell me. Anyway, so if we in nature, as I said, usually electrons, all the time, they want to be at lowest energy possible. That's why if there is a substance, and this is kind of the thing that we're trying to teach. Do you remember at the beginning of the section, I said that if you have hydrogen in a blimp and there would be an accident or leak or whatever, it just burns immediately and kills everyone in the blimp. But if you have helium, that's not the case, because they have different reactivities. So why that is the case? Because if something is reactive, is unstable, so it can be really, with a little trigger, it can be really unstable and wants to react to release the energy and goes to the lowest level of energy. So remember, in nature, everything, including electrons, want to be at lowest energy possible. Is that clear? So if I give you true or false, that in nature electrons want to have as much as energy as possible. True or false? They always want to be at lowest energy possible. So in nucleus, when your orbits are close to the nucleus, they have lower energy. And when they are like further away, they have higher energies. Think of it this way, that it's kind of like if you have like electrons here, because you have like positive charge here and negative charges here, it seems like they are constrained. And they cannot go out of their way to do, to participate in any reactions. While the ones that are here, it's as if nobody's watching them. They are just so active. It's kind of like parents that they're just like watching their kids, So if they are like someone watching you all the time, probably you don't have flexibility to do things that you want to do. But if nobody's watching you, you can just do whatever you want. Does that make sense? So if you learn the things that I'm telling you, it would be, much easier to teach for me and learn for you the things that I'm telling you next. So you can think of this. I'm going to go to the next page. So you can think of Bohr energy as a Bohr energy ladder. As we said in the previous picture, if you consider like this is the nuclei, and then here are like your different orbits, right? As I said, if you have like one electron, this electron can be here or here, but it cannot be here. It's kind of like walking on a ladder or climbing a ladder. I appreciate it, all of you, listen. And, I don't have, attendance. So if, it's boring or like you don't learn, you're free to leave the class, But I need all of you guys' attention because I'm trying to teach you quantum mechanics, which is not something really easy to teach. I can just teach and then go and hope for the best. But I want you guys to learn. So I appreciate if all of you pay attention. So it's kind of climbing a ladder. Can I just stand here by myself? Unless I levitate or have supernatural powers, I cannot do that, right? So this is kind of like electron. Electron can be in this. It can be here or here, but it cannot be between each of these steps. Is that clear? So this is how electrons are in an atom, in the Bohr model. And here, we have some definitions to save time. I'm just having it here. I'm going to underline them. And I ask you guys to memorize them because I'm going to ask you in the test. Most of the time, true or false. Is this true or false? And you should know it to be able to identify if it's true or false. So the energy of each Bohr orbit specified by a quantum number, n equals 1, 2, 3. And you remember, these are n equals 1, n equals 1, n equals 2, n equals 3, and so on, right? Is also fixed or quantized. It means the concept that we said, that it has certain amount of energy in each of these orbits. But it cannot be in between. So the electron cannot be in between of n equals 1, n equals 2. It's either in each of those orbits, and it has a certain amount of energy. And also, we have a definition, quantum of energy, which I'm going to explain. So now we're trying to relate those two observations. One of them was, as I told you, if we have, I'm going to show the picture again. If we have different elements, depending on what elements we have, we see different lines in the spectrum, right? And what are these lines? This is the thing I'm trying to demonstrate. So imagine for hydrogen atom, you have like just one electron, and the electron is here. If we heat this hydrogen atom, or like by giving it electricity, or like warming it up, by any means, if we give it energy, this electron, depending on how much energy we give to it, it goes to the other orbit. If we give it a little amount of energy, it comes here. If we give like much more energy, so this is the thing I'm trying to demonstrate. Each of these orbits, they have energy associated with them. It's a certain amount of energy, and electrons cannot be in between. That's why this amount of energy is quantized. Right? Yes.
For like molecules that have more color showing, like on the top one,
Uh-huh.
does it do that because a lot of its electrons aren't stable?
So all of these are atoms, right? But depending on, and this is the thing I'm just going to explain. So if I just say this, probably it answers your question, but if you didn't, just like ask me more questions. So imagine for hydrogen, if we have like one electron, and this electron is situated here, and we heat that up. And then imagine the electron comes here, right? So now I'm just talking about this. It's the initial position, now it's final position. So now it has more energy, but it's not the lowest energy possible. As I just told you guys, the lowest energy possible is when it's near the nucleus, so where it was. So atoms usually are in their ground state energy, meaning lowest energy possible for them. So when we give it heat, it goes to the next orbit. So now it's unstable. It wants to go back to the previous state. So what it does, it goes back. Now, I guess I just demonstrate this one because this is much easier to demonstrate. So it goes back from here to the initial state, and it releases energy. That's why you see these lines. And depending these different lines, it depends on which orbit it traveled to and now it's coming back. So it's possible that it went from like in n equals 4 to n equals 1, or like from n equals 3 to n equals 2, right? Or if we talk about n equals 5, it can go back from n equals 5 to n equals 4. It can go to n equals 3, or like this one can further go to n equals 1. So there are like different combinations, and depending on which path it takes, you see different lines. Which obviously I'm not going to ask you about these specific lines, but you should know where they come from. You should know these emissions for different elements are different, and you should know that they're not continuous. So these are the things, and you should know why you have them. And your book did a really good job explaining that by just the picture that I showed you. That here, we have like the definition here. That if it goes to a higher energy, is now less stable, and electron quickly falls back or relax. This is how your book explained that, but falls back or relaxes to a lower energy orbit. It's kind of like moving down on a ladder. And it releases a photon of light containing the precise amount of energy called a quantum of energy. So when going from n equal 2 to n equal 1, it releases an exact amount of energy that we call quantum energy, right? And that's here, it explained that, these lights can have like different wavelengths, and depending on that wavelength, you see that line in the spectrum, and it's just like explaining what I just told you. And here you have like a picture of what I just told you, like better demonstration that the dots that I just did, that you have like an electron that when it's excited, and this is the other thing, when we give an electron energy and it goes to a higher level orbit or higher amount of energy, we call that now that electron is excited. And then when it goes back to the lower state, we say that now it relaxes to the lower state energy. But these are the terminology that we use. So here, if we have energy absorption, this electron excites to another level. But as we said, it's unstable. It wants to go back to lowest amount of energy, so it releases energy. That is why you see the light emission and then the lines in the spectrum. So, and here you can see that, your book does a good fancy job explaining that here, for instance, for this one, you see that the wavelength correspond to red light, or like this one, if it goes from n equals 4 to n equals 2, it's like this much. And I don't want you to remember numbers or colors. I just want you to learn how these things are taking place. So, any questions so far? So if I ask you which electron possesses more energy, electron that is in n equal 1 orbit, or electron that is in n equal 5, which one has more energy? Exactly. And if an electron from n equal 5 goes back to n equal 4, what phenomenon would we see? Yes? Yes, but what we see? Yes?
The light emission, but I also have a quick question.
Yes.
And do you see light emission when it jumps to a higher orbit, or just when it goes to a lower orbit?
When it goes back to lower orbit. Good question, thank you. Any other questions? Are we learning? Okay. Good. Yeah, I know sometimes, I'm struggling to say things, or like I cannot demonstrate what I want to say well, but I'm trying my best. So if, as I said, if you at any point you don't understand what I'm saying, or I say something wrong, just tell me, I won't be upset or like mad or anything. Okay, so now that I'm doing this and showing the book, which helps me save time and I can explain things better, I do the same with like the quantum mechanical model. So I was just thinking of, your book gave a baseball example, and I'm not particularly good at baseball. So I came up with another example, but you're studying this too. Maybe you guys relate with that example better. So you remember just what I just said, that we had like these orbits, n equal 1, n equal 2, n equal 3, and we said that electrons can only be in these orbits. They cannot be in between. It's kind of like the ladder, We can just like climb on each step or stand on each step, but not in between. So now there are like, later on in 20th century, there are like scientists that they did like some more experiments and realized the Bohr model is not completely correct. And the reason was, or one way that they validated that, for hydrogen emission, just this spectrum for hydrogen, the model worked really well, but for other elements it didn't work out. So they realized that it's not as simple as Bohr thought. So now the model that we have these days is the quantum mechanical model. And instead of orbits, which n equals 1, n equals 2, n equals 3, we have orbitals. And orbitals are the probability of electrons being in certain location. So the thing that we said for hydrogen, it worked out well and is correct, and it still is good to know those things because we're going to use them from now on. But we cannot exactly say that electrons is like n equals 1 or n equals 2 or n equals 3. So we don't have orbits. But what we have is orbitals, which I'm going to underline this here because it's really important. Orbitals are different from orbits in that they represent not a specific paths that electrons follow, but probability maps that show a statistical distribution of where the electron is likely to be found. So imagine I'm running through the campus, going around, going to the buildings, just like run all around the campus. And for whether I'm crazy or I'm a runner, so for whatever reason, just, as a thought experiment, imagine I'm doing that. I'm just like running across the buildings, you know that I'm like in UI somewhere, but you don't know where. So if someone asks you, we want to ask Lida a question, where is she? You probably, most certainly don't know unless you see me at that specific moment. But in general, you don't have an idea. You don't know where I am. But if I don't seek any help or I continue running for marathon or practicing or whatever, I continue to do that every day. Probably if there would be cameras or someone just monitors me, they get an idea of the probability of where I can be found. For instance, they say, okay, usually at 12, she's around Starbucks or like Co-op, in the campus or like somewhere to eat. Probably closer to 11, she's at, parking lot going home, or sometime around 10:30, usually she's walking to the class. I'm just like making examples, So you can find, if you use statistical methods or like monitor my movements, you can predict where I can be found based on patterns. So this is kind of like electrons in an atom. So you cannot exactly say where they are, but based on the patterns, you can predict the probability of where you can find electrons in a specific moment. Does that make sense? So this is the quantum. So this is, the main important thing here is orbitals. So instead of having n equals 1, n equals 2, so we have those in quantum mechanical model too, but electrons are not specifically in different orbits. They are in orbitals, and it's really hard to have a picture of that. Like, if I want to monitor my movements and, have a picture of that is like difficult. So for that matter, it's the same thing with the movement of electrons. And let me just, as I said, your book has an analogy between like baseball and, kind of like comparing orbits with orbitals. So I encourage you all to do the assignment that I just said, and encourage all of you and also people that are listening to the lecture to go to tutoring session, because I'm going to post your quiz soon. Even if I don't post before 5, 6, which I'm going to do, I'm going to give her the quiz. So go to her, talk with her, ask for help. If you have any questions about anything, just email me. I'm understanding. I work with you. Okay. Did you also send me? Oh, okay, perfect. Thank you. Yes.
Or would you prefer?
I prefer individually. I mean, I don't know how that would work. So you're sitting together and then one person reads the other. I mean, if I guess I should listen to it if I have the understanding that, because that is so hard for me to monitor if someone, but if you can convince me that you both learn, that's fine, I guess. Yeah.
Thank you.
Yeah.
So the cold core is following the schedule, so it's due on December 1st after break.
Yes, I'm going to post it today though.
Oh, okay.
Yeah. That's fine, that's fine. Oh, okay. Yes.
Did you want us to just like record like a voice
Yeah.
audio
Yeah.
for that? Okay, cool.
Yeah.
Cool.
Of course.